we can use our information about geometric series and their sum and how that's going to help us turn a function into a power series. So what we know from, I believe it was 8.2, that the sum of an infinite series, if it's geometric, that equation is a over 1 minus r, provided that the ratio is less than 1. So what we're going to take a look at is, well, let's go the other direction. Like, let's head that way. So if we have something that looks similar to this a over 1 minus r, so for example, 1 over 1 minus x, that we can convert it into a power series. So in this particular problem, our a is equal to 1, right? So I'm just looking to see what's in my numerator. And our r would be equal to x. And so then if I know a is 1 and r is x, I can convert it into a power series because they take on that same structure. Now, this is only going to be true, of course, if that ratio is less than 1. So that is kind of our goal, is first to recognize that we have some sort of function that we can model into that a over 1 minus r component. So that's going to be our first look, okay? So the key here is that it's got to take on that form. And so a doesn't have to be a constant. It can be a variable, like that is a possibility. And our r, in order for it to be a power series, though, does have to have an x term in it. Okay, so the key here then, so what we're going to be looking for is we need to have, like, whatever is going to fill in this box here will be my a. We have to have a 1 minus, and whatever fills in this box here will be my r. Okay, and then of course, if we have a plus, like if this happened to be a plus, then we know that our r would be a negative value. Okay, so that's kind of like our goals here. So what are going to be my steps? So first, recognize that we have that geometric sum formula, right? So this is the geometric sum formula. And so we're going to rewrite it into that format. So again, when we say rewrite it into that format, we want it to rewrite into the sum formula. So S is equal to a over 1 minus r. So the key thing here is to get that 1 minus piece. Like, that is the key part here. Or if it is a plus, then we know that our r is a negative. And so what is that going to look like? So let me scooch a little. So again, like, however you, there's different strategies here. So I'm just going to say, the first thing I do is I get it into the variable term on the left. Okay, so when I do this rewrite, I'm going to do bullets here to give a little bit more detail on what that's going to look like. And so I'm going to rearrange to have the variable on the right. In the denominator. Okay, so that's going to be kind of my first step. So I'm going to just do that over here. So I have that 4. So I'm going to put that variable piece on the right. And then once I rearrange my denominator, I'm going to create my 1 first. Okay, so then I'm going to create the 1 minus r. So I'm going to do that, and I'm going to do that by multiplying or dividing, however you want to look at it. By multiplying, that should say by multiplying by the reciprocal. Okay, so I'm going to then, so I have a 2 there, so I'm going to multiply the numerator and the denominator by 1/2, because my goal is to kind of create that 1, because that is one of the most important components. Okay, so let's go ahead and do that. So then I would have half of 4, which is 2. Be sure to distribute that into both of those terms. So that would be 1, and then plus x over 2. And so now I have, like, that piece of things. Okay, so now once I do that, now I'm going to identify. So I have that 1 minus r feature, even though r is positive, or plus x over 2, meaning r would be negative. So then I want to identify the pieces that I need. So a is what's in the numerator, and then r is, of course, that 1 minus r piece, so in the denominator. So for this particular problem, I would have a is equal to 2, and then my r is going to be negative x over 2. Okay, so r will be negative x over 2 because it's 1 minus r. And then one thing I forgot to mention, I just realized, was this whole idea of the center at 0. So if it is something other than 0, we would have to do a lot more work, right? So if it's not 0, then it needs to make sure, like when we set this up, it'll be a over 1 minus, and then you should have some sort of like x minus c piece here, right? So you would have to do some extra work to create that. And we'll see that in an example momentarily. Okay, so then once I identify those pieces, then now I'm going to just set up my power series. I'm going to abbreviate that. And so that's going to look like a times r to the n, right? And we're going to start at 0 and head to infinity. So I have my a, I have my r, so then my power series, so then I know that f of x, which is equal to 4 over x plus 2, so I'll put it back into that other format, is equal to the power series, so it equals 0 to infinity, of a times r to the n. So something that looks like that. So what does that mean? Okay, so let's make sure we understand a little bit about what that's saying. So that if I know what this interval of convergence is, so let's go ahead and find that. This problem didn't ask for it, but I want to make sure we understand what we just found and how we can work with it. So let's go ahead and do that. So if I want to find the interval of convergence, I would take my ratio, which is negative x over 2, and have it less than 1 because it's geometric. So I'm going to multiply both sides by 2, and then I know because I'm doing absolute value, that negative will be positive, so multiply both sides by 2. And so then I know my IOC, because my center is 0, would be from negative 2 to 2. So let's pick a value, say, let's let, I don't know, x equal 1. So if x were equal to 1, right, and I evaluate the function with 1, so that would be 4 over 1 plus 2, that would be equal to, what is that, 4/3? And so then the sum of this series right here has to be 4/3. So if I ask you, like, what is the sum of this series, and you knew the function, you would just be like, well, okay, replace x with 1, right? So I know that the sum of this series would be 4/3 because it's equal to the function itself. Okay, so I can also find the sum using our methods from 8.2. All right, so now if I go beyond the interval of convergence, then the sum would diverge. Okay, so we're outside of that approximation value. Okay, let's take a look at another one that is also centered at 0 here. And so for this one, so we are centered at 0 again, and so I'm going to do a little rearranging. So the first thing I always do is rearrange the denominator. So I'm going to have negative 1 plus x squared. Excuse me. And so then now the next piece is I want to make sure that this is a 1, right? So I just want to make sure that it's 1. So rearrange. Now I want to make sure that's positive 1. So I'm going to multiply numerator and denominator by negative 1. So that would be negative 3 over 1 minus x squared. And so I'm centered at 0. I have everything I need there. So then now let's identify everything. So a is my numerator. R is going to be, in this case, x squared, which is perfectly fine. Okay. And so then now I can write out my power series for my function. So then I know that 3 over x squared minus 1 would be equal to the power series. So in going from 0 to infinity of my a value, which is negative 3, and then r to the power of n. Okay, and there we go. So moving on. So let's do one where we're not centered at 0. So this one is, it takes a little bit more effort because we're not centered at 0, but that's okay. We can still work this out. So the steps here are going to be similar. Okay, but I'm still going to go ahead and write them out. And again, like, this is not like you have to do it this way, but because our goal is going to be still the same. All right. So first thing we want to do is rearrange that denominator. So that's not going to be different. oops, denominator. All right. So I'm going to go ahead and rewrite that. So that's going to be 1 over and then negative 4 plus x. So now the next thing I am going to do differently is I'm going to create that center. So we are going to work this just a little bit different from here on out. So I'm not going to create the 1 first. I'm going to create the center first. Okay, so I'm going to create the center by adding c and subtracting c. Okay, so because I can add and subtract the same value in the denominator, and that will be equal to 0. So I want to be centered at c. So remember, we want that x minus c format. So then I'm going to subtract c and then add c. Okay, so, and I can do that because that's equal to 0. Okay, so then we're going to group appropriately and combine like terms. So we're going to group for the x minus c, and we're going to combine like terms. So I'm going to head this way. So that's 1 over. So this is the part I want to group. And then I'm going to combine like terms here. So I have negative 4 plus 2, which is negative 2. And then I'm going to group the x minus 2 because I need that to stay grouped to say this is my center. And then now we're going to finish it just like we did. Okay, so just like the other side. So then we're going to get our 1 term. So create the 1 term in the denominator. Oh my gosh, why do I keep wanting to write a W? Okay, so then I want this to equal 1, so I'm going to multiply by negative 1/2. And so when I do that, I'm going to have negative 1/2 in the numerator. And then when I distribute this, that will turn into my positive 1, which is what I need. And then here, I'm just going to distribute it to the front. So that would be negative 1/2 and then x minus 2. And then now we're just golden, right? So now we've got everything we need. So I know that my a is my numerator, and then my r is going to be the positive 1/2 x minus 2. So then my original function, which is 1 over x minus 4, will be equal to the series from 0 to infinity of my a term, which is negative 1/2. And then my r term, so I'm going to write that as x minus 2 over 2, and then to the power of n. I'm not sure why I did brackets on that, but I did. Okay. All right, so there's my geometric. So this problem also asks us to find the interval of convergence. So this will be a good review for us for that geometric power series. So from our 8.8 A notes. All right, so I know that there is that work there. So I take my ratio, which is this piece, and I'm going to take the absolute value of it, and then I'm going to set it less than 1. So I'm going to go ahead and multiply by 2 because I need to get it into that x minus c is less than r format, right? So review those notes if you've forgotten that piece of it. And so I know my center is 2, my radius of convergence, so my capital R is going to be 2, right? Because we're looking at that x minus c is less than r. And so then my interval of convergence, so my center is at 2, and then I'm going to go forwards 2 because that's my radius of convergence, and back 2 because that's also my radius of convergence, so 2 plus 2 is 4. And 2 minus 2 is 0. So then that will be from 0 to 4. And then because it's geometric, I don't need to test my endpoints. And that is that.